Hello and welcome to our webinar, High Availability in the Cloud, Architecting Best Practices. Before we get started, we have a few questions for you guys. We're going to launch the polls right now. If you could take a moment and answer 3 questions for us, that will help us tailor the content of the webinar. So first question, are you using the cloud today? So Amazon EC2, Rackspace, anything that you personally define as cloud, select one. First option, yes, very much with one or more serious projects. Yes, you're running in the cloud and you have at least one project that's growing with importance. You're starting to explore the cloud, or no, you are simply not running in the cloud at all yet. Okay, we're going to leave this open for a few more seconds. Thank you so much for your responses. Okay, cool. A lot of you are doing serious projects in the cloud. That's kind of what we were expecting today, since this is a very specific webinar relating to a recent outage. So let's go on with the next question. Were you affected by the latest AWS outage? So there's a few options here. I'm going to explain them real quick. First one's obvious. No, you're not running on AWS, therefore you were not affected. No, you're running on AWS, but you were not in the East region. No, you weren't affected. You're running on AWS East, but you were not affected. Maybe you didn't, you weren't in the affected availability zone, or you didn't try to launch anything new that day. Or yes, you were running on AWS East and you were affected. A few more seconds. Interesting. So good split here. Some of you are just not running on AWS. I'm assuming that's probably the portion of the audience that's not running in the cloud yet. But of you who are running on AWS, there was a large number who were affected by the outage. So that's great. We're going to have a lot of good examples for you today and a lot of good learnings. Last question, real quick. Simple yes or no. Are you actively looking for design solutions to help increase your application availability in the cloud? Yes, you are, or no, you're not. A couple more seconds. Yes, many of you are. Great, and that's exactly why we're here today. So let's go ahead and get started with the webinar. I would like to introduce you to our panel today. I've got with me in the room Michael Crandell, he's CEO of RightScale. If you'd like to follow him on Twitter, there's his handle right there. I've also got Josep Blanquer, he's our Senior Systems Architect. And then as well, Brian Adler, he's our Professional Services Architect. So it's a room full of really smart guys who are going to help educate you today on high availability in the cloud. And then also I wanted to let you know we have a Q&A line open. Jason Altabelli will be answering any and all of your questions. So throughout the course of the webinar, any questions that you might have, feel free to enter those into the GoToWebinar questions panel. Some of those questions are going to be more generally applicable to the audience as a whole. So we'll be having Michael, Giuseppe, and Brian answer those live on the air. So again, ask your questions now, ask your questions throughout the presentation, and we will answer all of them. So with that, Michael, handing off to you.
Thanks very much, Sarah. And I'd like to make one additional shout out to Chris Horn in our product marketing department who helped us bring this together fairly quickly. Thanks a lot, Chris. We organized this webinar essentially to address the timeless questions in IT design around resiliency, et cetera, and keeping high operational excellence and uptime in systems. These are timeless questions, but of course, they come to the fore when there are outages like there were a couple of weeks ago. Just as a side note, I looked on the calendar today. Today is May 6th, and it happens to be the anniversary of the crash of the Hindenburg in 1937. You know, disasters do happen, and it's just human nature to, we tend to look at buying earthquake kits after the earthquake happens and fire insurance after the fire. But what we would like to do is take a step back, return to the philosophy that's really been preached, including by, led by Amazon itself since day one of the cloud, which is designing for failure. We're going to take you through a brief synopsis of what actually happened in the AWS outage. There's been a long, detailed response from Amazon. Thanks for that. And what was RightScale's experience there? And then dive into actual approaches around infrastructure abstraction and automation and how that can be used to develop HA applications. What are some architectural options to protect against cloud failures? And then conclusions, and give some give some time for a question and answer at the end. A little quick review of terminology. So these are some terms that will come up today. Just as a reminder, fault tolerance is really around leveraging redundancy and replication to enable entire systems to continue to operate if one or more component fails. So that's what we mean by fault tolerance. HA, or high availability, refers to uptime, essentially. Fault-tolerant systems are measured by their availability, how they continue to operate in terms of planned and unplanned service outages. So this is where the famous 5 nines of availability come from. That's the last bullet there, 99.999% availability. And you can see we've multiplied out what those various levels of availability mean in terms of acceptable downtime over the course of 1 year. Disaster recovery is the process, policies, and procedures related to restoring critical systems after a catastrophic event. So to get back to the main point of designing for failure, our view is that large-scale failures in the cloud are inevitable. They're also pretty rare, and especially when compared to other options, and I'll say more about that in a minute. But ultimately, we're all responsible ourselves for designing systems that are highly available and can be recovered. The cloud itself is not going to magically do that for you. I think that's a clear takeaway from recent experiences. So what you really need to get into is how to develop for HA, and also the different levels of developing for HA, and how you balance the cost and complexity of efforts against whatever risk or downtime you're willing to put up with as a business decision. The good news here is that cloud architectures and infrastructures have made disaster recovery and HA remarkably affordable compared to what anyone could do in the past. It really is amazing what options are available and what kind of systems can be designed at low cost. And these range from simple systems that use multiple servers to guard against a single, a component that dies in a particular hardware server, to solutions across multi-availability zones, solutions that span different so-called regions, and then ultimately solutions that span various cloud providers themselves. We'll be addressing each of those in different ways today. But it's good to keep in mind there are all those different levels of solutions. And one analogy that was used, I think it was Lou Morman from Rackspace, I think it was a great analogy. He said, this outage is like an airplane crash. It does happen, but and when it happens, it's catastrophic from a carrier. But we have to keep in mind that, relatively speaking, it's still safer to fly on the carriers than it is, I think he said, to drive on the freeway, which is statistically correct. I took a look at another site which had some information about different levels of crashes and cost on different types of flying. And it turns out that this set of data, which covered, I think, 5 or 6 years earlier in the 2000s, shows that it's actually safer to fly on large carriers in terms of fatalities per million hours flown than it is on small aircraft, which, by the way, are also more expensive. So to the extent there's an analogy there, the public cloud failures are very publicized and visible, but it's important to keep in mind that by and large the operational excellence has been very high. We expect it to be very high, and it indeed is probably higher than sort of small-scale build-your-own solutions. So with that, quick review of what actually happened in the outage that started on April 21st at Amazon Web Services. I think we all know this, but quick review. It was triggered by an operator error during a router upgrade, and that caused a lot of high-volume network traffic to be directed at a low bandwidth control network that was used by Elastic Block Store. So this is the mountable volume storage capability. It flooded the control network, which caused a lot of EBS servers to be effectively isolated from one another. Those are all based on the notion of volume replication. And so it broke that notion, and it caused these servers to start re-replicating the data to fresh servers. This basically caused a large-scale re-replication storm that had two effects. First, it caused the volumes, in many cases, to go offline, which prompted the need for manual intervention. The re-replication would fail, and it caused that. And it also flooded the EBS control plane with re-replication events that affected its operation across the entire U.S. East region. I think that was an unanticipated consequence that spilled across the notion of isolation of availability zones and began to affect more than one availability zone. So it's important to realize that was not intended. It was not the way AZs are designed, but it did happen. AWS took steps to deal with this by stopping the re-replication to kind of quiet down the system and prevent new volumes from being drawn into the outage. They went ahead to isolate the affected AZ from the control plane in order to restore normal operation in other zones, and then they began to recover the volumes through a variety of techniques. I think we believe at RightScale that their response was amazing, that they were pulling off just amazing response to an unexpected situation in real time, and they did quite well. So that's our sketch on what happened, and now I'd like to invite Josep to comment on what was RightScale's experience during this.
Yeah, thank you, Michael. I thought it was probably interesting for people to see a little bit what we were seeing while all this was going on from the guts of RightScale. So basically how this impacted our infrastructure. Really what happened to us was that kind of early morning we started seeing some of our monitoring servers that have really high I/O disk, that they need really high I/O disk performance, to start basically crawling to a halt. So initially when our alerting system and everything notified us, and we started trying to recover some of these servers by launching new ones with new, fresh EBS drives. Well, that immediately failed because there was no way you could create new EBS drives in the affected zone. So then the next step was, all right, well, let's relaunch them completely in a different zone, which should be possible. And at that point, Amazon, as one of the preventive measures that they took, they basically shut the possibility of creation EBS volumes on other zones too, while things kind of recovered little by little. So when we tried to relaunch these servers in a different availability zone, we also failed. We could not create new EBS volumes. So around, at 3 a.m. approximately, we realized that this was not going to be something that was a quick fix. So it was time for Plan B. Basically, what we did at that point, we revamped our monitoring server template. So basically, the server template is what defines the configuration of a server when it boots. We revamped it to remake our monitoring servers to use the ephemeral drive, the local drives in the servers, instead of relying on EBS. So within about 20 minutes, we had that done, so we could start relaunching these affected servers with the new template. So effectively then we would have a few servers that run on local drive and had less basically data redundancy while the outage was going on. So it was pretty interesting to see that by just changing the server template, we could easily have a fast way to recover servers that were completely dead using EBS. I mean, of course, this was also possible because our internal architecture of these servers basically restores monitoring data from S3 on demand. So we just can launch a new one, and the data will appear on the local drives. So we thought that we were out of the woods from that perspective, and yeah, we kept continuing to relaunch new servers. And at 7 a.m., Amazon announced that certain things were fixed. So we thought that was only downhill from there in terms of easier. But at around 11 a.m., one of our disks in our master database got hit with the same problem. So at that point, there was nothing we could do about trying to recover that disk. So our reaction to that was basically choose from our one of our many slaves that we have. In particular, we choose one from our zone 1D, which seemed to be the least affected throughout the night, and we promoted that slave. So within a few minutes, really, we could recover our master database and be up and running. It actually took a fair amount of time to get that new slave up at the performance that we want it to be, because the working set of the data was fairly cold, and we have done things in the past to make that recovery faster, but in this case was a bit of a last minute thing. So yeah, there's some things that we can do. We can try to plan for next time, but in a sense, it came down to realizing that our master was down and selecting one of the slaves and clicking the promote button. So that's kind of what our overall experience with the outage was. There were some other systems that failed here and there, but our redundancy, internal redundancy, made it non-issue for any of the customers. So.
Right, and when we get ready to move on here, Joseph, one question that came in so RightScale clients weren't as badly affected as straight AWS clients? Basically true, presuming that they designed according to the principles that we normally preach and help people implement as they're using RightScale.
Right. Probably, in a sense, the amount of automation and redundancy that you can build within RightScale it's not going to prevent you from having a single node, be affected, but you would be able to recover much faster, or even not feel it if you have enough redundancy. Yeah. Okay, so the next thing I want to talk about is kind of step back a little bit and go over some of the interesting abstractions that people should be thinking of when designing for these HA concepts. So in general, these concepts are fairly high level that can be applied to any cloud and in any way of management, but then we'll basically link it back in how we help you with, from the point of view of RightScale, to think about these terms to begin with. So before we start, basically, to clarify what we mean by a cloud is it's really a pool of resources that are behind an API endpoint. So a cloud could be Rackspace Cloud in the Texas data center. They have another one in Europe. Another cloud could be Amazon East. Another cloud is Amazon West, Amazon Japan. Those are different clouds, as well as any of your private clouds. Right? So it's important to know that a cloud is not the cloud is not an availability zone or Amazon Web Services itself. It's just it's a combination of services. So that's what we mean by cloud. Now, when you are trying to design for failure, potentially a complete cloud failure, it means that you have to be able to interact with different clouds in concepts that well. So, and that's fairly difficult. There's many pain points in thinking multi-cloud because the APIs of these different clouds may differ. They may not support the same set of resources. Some clouds may have EBS and snapshots, and some other clouds may not. The formats in how you interact with them are different. The security aspects of it are different. The IPs, different hypervisors, different machine types. Different clouds may be really, really different from each other. So the first thing to think about is that whenever you design your architecture, try to design it using generic concepts that can somehow be applied to the different types. And then only when you actually have to deploy and manage them, use the cloud specific. So make sure that you use the goodies that each cloud provides, but don't lock your architecture based on that if you can avoid it. Right? So then from this perspective, you need to have these tools or these platforms that allow you to translate these high-level concepts to whatever the cloud actually provides. So an important thing of this translation is you have to start thinking about how to share resources across clouds. An important difference between different availability zones in one cloud or different clouds is that across clouds, nothing is shared. If you want to move a piece of data from cloud A to cloud B, you will have to do it your own. The cloud is not going to help you. Same thing for changing IPs or changing snapshots and things like that. So that's basically the idea. Just design at the high level. And then I think that one of the important points here is that you can start by going from the low level to a much higher level construct. So for example, you have things like instances that are really cloud resources that you want to detach from and build some concepts like a server, which is kind of a runnable abstraction. So in RightScale, for example, we have this concept of multi-cloud servers, or server arrays, which are really constructs that allow you to define how you want these nodes, these servers, these instances, however you want to call it, however your cloud calls it, in terms of configuration. You want to say that you have certain CPU, certain disk, and certain characteristics. So that's the server. So when you create a server, say in RightScale, you're really designing something on paper. The cloud doesn't know about it. It's not until you actually start the server or launch it that we do make this translation into whatever type of cloud that you want the server to be. So the same thing you can do from a point of view of the configuration of the software in this server. That's something we call a server template. Server template is a design concept that lets you say what software and what things you want the server to have when it's up and running. And then again, the cloud doesn't know about it until you actually have implemented that server or launched that server in a different cloud, right? So our server templates can use Chef, or they can use scripts. So it's very, very configurable from that perspective. And then the third aspect to it is that you have to worry about the base image that all these servers will need to use. So you don't want to rely on particular AMIs or whatever the cloud calls it to be in each of the clouds or availability zones that you need servers to be booted on. So you want to have this high level construct that allows you to specify, I want this type of image with this OS, this architecture, and this basic software installed in it. And then somebody like RightScale will map it to a particular AMI or whatever resource that exists in the cloud. So in some ways, basically what I'm trying to say here is that try to define your architecture with building blocks that are cloud agnostic as much as you can, and then have tools that allow you to map these constructs to cloud particular resources. That's basically this red line that we see here on the right. So now, if you go from cloud resources to higher level abstractions like this slide, you can also go one step further that you will need for real production systems, and that is that you need full management of all these high-level resources basically in a runtime configuration. You need to have a way to see these resources from a single pane of glass. You need a way to automate how you put together really quickly all this provisioning of servers, the configuration management of the software of the servers. You need to be able to monitor and get alerts from all these servers. You need to be able to do things like auto scaling or dynamically change the configuration of these servers over time. So basically, you need a platform that can run under these higher level abstractions. I think that you don't want a platform that can only work for a particular cloud. So you need these middle ground abstractions to really have an architecture that allows you to shift things across clouds, quickly develop or change in cases of failure. And finally, it's also very important that whatever the platform you use, you want to have a big array of software options to choose from, right? And that's kind of, in some ways, these are the main bullet points that the RightScale platform basically help you with. We have obviously a single pane of glass for through the UI and the API for managing all these servers and templates, configuration, and multi-cloud images. We have the alerts. You can configure the alerts exactly in the same way, regardless of which cloud. The auto scaling and the monitoring is again the same for all the clouds. And we provide a large library of templates, meaning large library of preset configurations of software that you can leverage, because you don't really need to reinvent the wheel if there's many users already using that particular software. So I think with that, I'll hand it to Brian
Thank you very much, Joseph. And before I get started on some of the architectural options that we're going to be talking about, the webinar organizers wanted me to let everyone know that there's sort of a chat going on about this topic on Twitter. The hashtag is RightScale HA, RightScale High Availability. So RightScale HA is that hashtag. Okay, so I'm going to kind of quickly go through here what we have sort of as a checklist, and some of these might be self-evident, and more of them will become so as we get a little deeper into the next few slides. But I want to sort of start at the top here and talk about you need to determine who owns your architecture, both application and your infrastructure, as well as the disaster recovery process and your testing. Those oftentimes will not be the same person or group, and they really shouldn't be the same person or group. Anybody who's done software development knows that the best tester is not yourself. It's someone who doesn't know how it's supposed to work because they're going to do all the crazy things that you're not supposed to do. You want to develop some expertise in-house or get some outside help to assist you in doing these HA and DR designs. Conduct a risk assessment on each app. Figure out where the pain points are, where the availability concerns may be. Specify your RTO and your RPO. The more aggressive they are, the more complex and or costly your solution around them is going to be. As Michael stated from the very beginning, you want to design for failure. Basically assume everything's going to fail and find ways to mitigate around that. Obviously, implementing HA best practices is always going to be that balancing act between cost, complexity, and how risky, how likely is this particular thing I'm worried about going to be to happen. You want to document your operational processes and any automations you put in place, because granted this is going to happen at 3 a.m. when you're sleeping. You need to be able to look at something and do it from a documented process as opposed to trying to remember how did I do this last time when it actually worked during testing. Which leads us to the testing. Make sure you test it. Test it again and again and again, and make sure you've thought of everything. And then to use sort of the Netflix concept, they mentioned their chaos monkey. You want to release that chaos monkey. Let that person or process go crazy. Kick out every cable. Spill coffee on the keyboard. Push the big red button that says don't push. Do all those things that you don't think could happen because at some point they will. Okay, so architecture deployment options. And some of these are cloud dependent, and we'll talk a little bit about each of them, but sort of the general concepts flow from cloud to cloud or region to region. Storage options. You've obviously got the local storage, and depending on the cloud you're in, you may have the EBS, the Elastic Block Store, which is obviously what caused a lot of the outages on the 21st and the 22nd. S3, the redundant persistent storage, or you might have cloud files. We've also partnered with the folks at Gluster with their Gluster FS, Gluster file system, to provide sort of a higher performance, more distributed file system. And we can hook you guys up with them if you're interested. DNS configuration options. We always recommend using DNS APIs to allow you to do dynamic configuration of DNS. And our templates currently support the three you see here, Route 53, DynDNS, and DNS Made Easy. Load balancing options. Vast majority of our customers use HA Proxy. Some of them also use the Amazon Web Services Elastic Load Balancer, that's the ELB. But the only caveat there as we go forward talking about true multi-cloud deployments is that if you want to have the ability to run in multiple clouds or potentially forklift your application from AWS to another cloud, you need to avoid using cloud lock-in, vendor-specific components such as ELB and RDS, which we'll talk about in just a minute as well. Server array options. You want to create these scalable tiers of your web and or application servers so that your servers scale across all the availability zones of the particular region or cloud that you're in. Database options. MySQL and our database manager server templates, those who are familiar with it, allow you to do EBS snapshots to S3. You can also use the local disk and use LVM snapshots to S3 or cloud files or whatever your storage flavor of choice may be. It assists with those automated snapshots, that replication, promotion of slave that Josette mentioned earlier that we did sort of addressing the outage from our side of things, as well as striping across multiple volumes, which will allow you to get a little better I/O performance as well as potentially create larger logical volumes than are possible with a single volume. AWS's RDS, Relational Database Service, we talked about. Again, that's a sort of a cloud lock-in, if you will, and migrating off of it can be a little bit cumbersome. So that's something to be aware of. You can also use things like database sharding techniques. We partner with the folks at Code Futures that have assisted a lot of our customers with basically partitioning their databases and distributing them for both performance and availability concerns. And then lastly, NoSQL databases. If you don't have those relational needs within your application and a NoSQL solution can work for you, then it might make sense to distribute the primary and replica nodes across multiple AZs and multiple regions to help give yourself some additional availability and resiliency to failure. Real quick, a couple general HA best practices, and a lot of these are probably pretty evident, self-evident, but avoid single points of failure, obviously. We always recommend you place one or more of each component in at least 2 availability zones and or regions and or clouds. You want to maintain sufficient capacity such that if an AZ does go down, you have the ability to absorb that traffic. You don't want to be running right on the hairy edge where all your servers are CPU loaded, so if you lose one of them, all of a sudden you start getting 503. So you want to have enough servers that are somewhat idle so that if you did lose some of them, the others can step up and take that without your end user seeing any noticeable or appreciable degradation of their application. You want to replicate data across the AZs, and we'll talk a little bit about this in some of the slides that are coming up and show you sort of pictorially how you can do that. You want to set up monitoring and alerting. You want to know about problems before they become problems. That's one of the things that we were able to do here. We use our alerting and monitoring, and we pretty much found out what was going on before, well, I don't know if it's before anybody, but definitely before it was posted on any of the AWS forums or the status pages. And lastly, you want to design stateless applications if at all possible. That way they're resilient to reboot and relaunch. You don't want to have any persistent data or any required session data in your applications because when they go down, that session data would be lost. Okay, so what we're going to show here in the next few slides are sort of different pictorial examples of different architectural options that you have. This is the multi-availability zone, multi-AZ example, and this is what we recommend to almost all of our customers that come to us to the RightScale Professional Services organization. And what this basically shows is that we've distributed the deployment across multiple AZs within a particular region. So, for example, you have a load balancer in each of these regions, in each of these availability zones of the region, and your server array grows across all of the availability zones. For simplify the picture here, we only have 2. US East actually has 4 AZs, so the way that we standardly set this up would be to have the application server scale across all 4 of those availability zones. And also you'll see you have a master and a slave in different availability zones, and Joseph talked about that as well, is that we had multiple slaves running in multiple AZs, and we chose the one that we thought was the least impacted when it came time to do our promotion. Now, you'll notice that by default, we snapshot the master every 4 hours and we snapshot the slave every hour. And that's so that you can hopefully easily recover any data within that region. And as I mentioned, you place the slave databases in 1 or more AZs so that you have that added availability and resiliency. You may want to consider local storage for additional slaves so that you remove that dependency on EBS. And you can then use LVM snapshots to back that up to S3, for example, or Cloud Files or some other storage repository. Now, the one thing to notice here as well that I did not mention is the little $signs that you see. And those denote zone-to-zone data transfer costs. And that currently within EC2 is 1 penny per gigabyte, 1 cent per gigabyte. And that's generally a cost that most of our customers are willing to absorb to add this availability to their applications, but it is something at least worth denoting. Okay, so I'm going to kind of digress here. Oh, I'm sorry, there's one more bullet point. The NoSQL databases, which we touched on the previous slide as well. And that is, if you can get away with a NoSQL solution, then you can go ahead and distribute those NoSQL nodes, both the primary and the replicas, across availability zones to help assist you with that availability of your application. Okay, we're now going to touch briefly on sort of DR. We're going to sort of digress real briefly into disaster recovery because it leads nicely into our last topic on high availability. So I just want to talk a little bit about what we refer to here as the cold, warm, hot versions of disaster recovery. And the graph here is just basically to depict to you sort of the cost versus downtime trade-offs that you go through. Cold DR is the most common one that a lot of our customers use, but it also has the longest road to recovery, if you will. And we'll look at these in visual examples here in just a minute. The warm DR is the one that we generally recommend when folks come to us because that's the least amount of cost. Well, the cost versus recovery time trade-off is generally the best. There's also hot DR, which is the least common, and that's the most costly. And then lastly, that is very closely tied to what we're calling here hot HA for hot and high availability. And we'll talk about that in just a minute as well. So here's our multi-cloud cold disaster recovery example. And what you see here is you have a staged server configuration. And what that means is in Amazon EC2 US East in this particular example. And a lot of what we're showing here is showing within EC2 regions, but the same concepts apply to multiple clouds as well. But there are some caveats, the ones that Josette mentioned in his part of the presentation about you might not have the same concept of EBS volumes or the same concept of elastic IP or whatever it may be. So there are some challenges, but at least the concepts that we're going to show here are usually cloud portable. So the cold DR example, again, you have the servers that are non-operational in the US West, and using the RightScale platform, you have the ability to clone essentially your entire deployment and put that deployment in a non-operational state in another region. And so in the event of a failure, if the US East was to go down, you would need to get that data from Amazon S3 into this other region. And again, granted, there's some challenges there, but the point is you need to get your slave database up and running, operational, promote it to master, and once that's done, you can then go ahead and launch the other servers within that region. So you're able to get up and running. It does take some time, obviously depending also and primarily on the size of your database and how long it takes to get that to an operational state. So if you compare and contrast this cold DR with the warm DR example, it looks very similar. The only real difference here, as you see, is that the slave database and the attached EBS volumes are live, and you're replicating data from the master to the slave in the other region. And you notice the $ there. Now, there is obviously cloud-to-cloud or region-to-region data costs, which are higher than the inter-AZ costs that we discussed earlier. Now, the concept here is that if you were to lose the entire US East, your slave database is probably at least up-to-date or fairly close. If you need to recover any bin logs, perhaps, you can pull those over, get them onto the slave database, promote it to master, and then do the same thing you were going to do before, which is launch the additional servers within that region. And if you're not using read replicas or read-write splitting, you can even launch the slave concurrently with those application servers to even minimize your downtime further. And then the last example, at least in the DR world, is you have the hot DR, hot disaster recovery. And this is where it looks a lot like the warm. The only difference is you have all of the servers are running, and they're always up, they're always running, but no traffic is being sent to this US West region at this time. Now, the reason this is more costly is that you're still doing the data replication like you were in the warm example, but you also have all these servers up and running that you're paying instance hour costs for that you don't really need. So this obviously has the least amount of downtime. If you were to lose the US East region, you just need to make sure that your slave database was operational and up to date, promote it to master, and then just make some DNS changes to switch things over. Now, the reason we kind of built up this DR example was because what you'll see here is an example of what we're calling sort of hot HA, hot high availability. And this is where you have availability that's implemented by implementing your application across multiple regions. So it looks a lot like the previous example, but we'll talk about the caveats and the differences here in just a minute. But what you'll see is that you have both regions or both clouds are servicing traffic to your application. And you have, again, additional $ on here as you have that inter-region data transfer costs. All right. So now multi-cloud looks similar to multi-AZ, but there are some additional problems that you need to solve because not all resources are shared across clouds. And particularly some are shared across regions, some are not, and definitely not going to be shared across different vendor clouds. So for example, images for the cloud servers are specific to the cloud and region. And the RightScale server template, and particularly the MCI, our multi-cloud images, assist you greatly here in that you can have a server template that's built on a single MCI, and that MCI will have images that will run in all of the supported regions. You need to deal with DNS. Elastic IPs don't cross regions and definitely don't cross cloud vendors. So you need to worry about, and that's where we talked about those DNS APIs to allow you to quick and rapidly switch your DNS entries. And that's where it's also important to keep your time to live, your TTL short, so that if something like this is happening, you're able to switch your traffic over relatively quickly. You need to copy or replicate your data yourself, right? Because EBS snapshots, as many of you probably know, are region-specific, and you can't use that same snapshot in US East that you can in US West. So you have to solve that problem. And obviously, if you're using a different cloud vendor, you have to solve that problem. So there are some challenges here. Another one that's not depicted but is relatively important as well is security groups, right? Security groups do not cross region or cross clouds, so you need to implement firewall rules or make sure that you can solve those security group or access permission accordingly. And so with that, I'm going to probably hand it back to Michael so he can deal with our conclusions and our wrap-up.
Thanks, Brian. So, ultimately, it all comes down to the question, so what's the best approach to achieve high availability? Well, we always circle back to this original principle, you need to design for failure. We're sort of harping on that ad nauseum, but it's the truth. Secondarily, when you try to design that way, there really is no one-size-fits-all solution. There is no silver bullet here that will magically solve everybody's problem in every case. The reasons are that every application and every set of componentry, whether it's a database or application server architecture or some other app-level construct, has its own architecture and therefore its own considerations around redundancy and resiliency. Also, there are real trade-offs between levels of resiliency and the cost involved. And that ultimately becomes a business decision of how much risk you're willing to accept in relation to how much cost. However, the good news is that the building blocks at your disposal to solve this problem, the options available in cloud computing today, are really unprecedented. You have the capability, if you stop and think about it, of launching resources anywhere, almost anywhere in the world. Even within Amazon alone, we're talking about, I think, 5 different regions. Within 10 minutes. Within 5 or 10 minutes, you can have resources running. You can have them running at very low cost on a warm basis or a hot basis, as was just mentioned. The time to access and put those resources into play is extremely quick. We're not talking about faxing in an order to a colo provider and buying some hardware and standing it up. You're talking about launching cloud resources through automated APIs. And the investment required, while there is additional investment to mitigate the risk, it's quite low. Again, imagine more than 5 years ago trying to get access to resources in all these different geographies, or even within separate data centers within a given geography, was very, very expensive. So ultimately, what we recommend is follow the HA checklist that we reviewed earlier. It's the reason we built that is it's our best thinking about considerations you should keep in mind to achieve HA. And by the way, we're here to help with that. In these webinars, we try to provide a lot of specific, actionable information for those who are interested in doing it themselves. But for those who aren't, that's RightScale's business. And really, it was interesting. In light of the topicality of this recent outage, it's become on everyone's mind, but it's something that we've been designing for since the inception of the company more than 4 years ago. And so, in fact, this month we do have a special offer around an HA assessment and design recommendation package for those who become a RightScale customer in the month of May. We're offering a free HA assessment either of your plans to move into the cloud or your existing deployment there, with free design and architecture recommendations and a discount of half off the typical onboarding fee. And really, just as a reminder, in terms of RightScale services, we really provide 4 different major things to companies that are interested in refining their implementations on the cloud or in moving to the cloud. The first is premium onboarding. It's a person-to-person system as you begin to migrate to the cloud that deals with HA issues and other design issues, as well as down to very practical details. We do implementation engagements. These are typical professional services engagements around projects. We do virtual on-sites where we'll do trainings or consultations using virtual web conferencing and other software to deal with your staff directly. And we also do deployment reviews. That's in the case where you're already using a cloud infrastructure, you already have an implementation there, and you just simply like to review, get some outside help on, is it resilient, what are the failure scenarios, and how to deal with those. So with that, I think we're coming to the end of the formal part of the presentation, and we're going to open it up to questions. So why don't I start, Josep? I see you have a stack of Post-it notes there. So why don't you start off and go through 2 or 3 questions and go ahead and answer them.
All right, let's see. The first one here says, can RightScale share what they did internally? It doesn't make sense to reinvent the wheel. The fact of the matter is that we are already basically sharing what we did. Our master-slave automatic promotion is basically one of the server templates, one of our most well-known and used server templates for our customers. So that's already there. What we did for our monitoring servers, this is very much a RightScale service. So there's nothing really, that can be shared from that perspective. Another question is, after the slave promotion, you were running off of the master. Were you able to switch to the master of your other slaves. I'm not sure if I understand correctly, but basically what happened is when you promote a master, you have to change the slaves or launch new slaves to basically be replicating from the newly promoted master. So that's kind of what we did in our case. Will RightScale update the MySQL database manager tempted to have an option to fall back to ephemeral? I think it's a possibility. If we see that this is a good thing for our customers, I think that wouldn't be that difficult to do. The caveat there is that if you try to do this with the master database, you're running with very, very low redundancy unless you have enough slaves replicating from the ephemeral. So it's a bit of a risk, but I think actually it's a good suggestion that we could potentially implement.
Well, Joseph, I've got quite a stack here too, so I'll jump in and answer a couple of these. The first one here is, it's interesting, it says, so the problem could be avoided if EBS storage wasn't used at all. Well, the answer is for this particular outage on April 21st and 22nd, yeah, I guess that's kind of true, but the point being that this was one of many types of things that can fail. And as we talked about, when you really design for failure, you need to assume that everything and anything is going to fail. So to answer the question strictly, yes, but that doesn't mean that you're going to avoid the next particular failure. I won't mention the company, but I remember reading a blog just over the last couple of days where they talked about how well they had architected around this whole thing, and the very last sentence was, oh, and by the way, we don't use EBS. And I was like, well, that's kind of pointless. You guys didn't really architect around this. You just happened to avoid the failure component. But the next question I have is traffic from each zone on a private network or the public internet? That's a good question. Within a region, so for example, in US East, you have the 4 AZs, A, B, C, and D. The traffic between the AZs in that region is on a private network. You can use the public IPs of your instances, but that's not advisable. If you use the 10.x network, everything between A, B, C, and D is on that private network. If you go cross-region, I should say, so from US East to US West, then you are traversing the public internet and you are inherent to the delays and costs of that data transfer. Next question is how do you snapshot? I assume it says, how do you snapshot from EC2 to S3? Well, that's a little tricky, right? The way that EBS snapshots right now work is that they do get uploaded to S3, but you don't really see them. You see them as snapshots, but they don't show up in a bucket, if you will, and those types of things. Some of our tools and some of the server templates we have coming out shortly will also allow you to do, in addition to EBS snapshots, you'll be able to do LVM snapshots of your volumes. And those LVM snapshots you'll be able to upload directly to S3 and or cloud files, et cetera, for the other storage options that we'll support. So right now, the EBS snapshots go to S3. You can't really get to them, but using some of the tools in our toolbox and particularly some of the templates coming out in the following sprints, you'll be able to do that using LVM snapshots directly to S3.
Okay, I can take a couple more. One quick one says, if using SimpleDB, is it possible or necessary to replicate data between regions? No. SimpleDB is a completely different service. The fact that it's from Amazon, it's really not tied necessarily to this multi-region, multi-AZ constraints. Another one, that's a very good question. How can we have security groups and replicate EBS snapshots across multiple regions? So security groups is an interesting thing. So security groups will only work within a region. So if you really want to maintain security groups across regions, you need to have tools that can actually maintain that across. And at RightScale, we're actually thinking about these higher level abstractions. This is very much another of these higher level abstractions that I was talking about that you have to be able to put yourself. And then another one is a very interesting one too. It says, if I have two of my own Eucalyptus-based private clouds, would RightScale be able to help me make AWS my backup solution in terms of reproducing the whole and launching a whole bunch of instances? The answer is absolutely yes. And that exactly speaks to the high-level constructs that the RightScale dashboard is built upon. You have your servers, you have your configuration, your alerts, your images, your multi-cloud images, your server templates are exactly the same. And it's up to you to say, now I'm going to clone these servers, configure them for that cloud, and launch them in exactly the same way. So absolutely.
Hey, Joseph, great. I'll jump in with a couple here that are, thank you very much for these questions. These are awesome. They keep coming in. Someone here asks, how are you securely replicating data from a master to a slave database in a different region? And that sort of touches on what Joseph had mentioned in his multi-cloud, sort of what is a cloud, what does multi-cloud really mean slides, is that can be tricky, right? And those are some of the hoops and hurdles that you need to jump through. But for example, what we've done here in experimentation, as well as setting up some of our own internal deployments, is MySQL has its own SSL-based replication. So you can use SSL certs when you're using MySQL, and you can go ahead and do that secure replication from the master to the slave. What we've also successfully done is we set up OpenVPN, where our master database in one region was our OpenVPN server, and we had a slave database in another region, which was our OpenVPN slave. And they actually replicated across what appeared to them to be a local area network. We set up a 192.168.1.x network, and they were actually replicating across that network, even though they were in entirely different regions, and they were able to leverage the OpenVPN secure tunnel to do that. Question here is, how can we share security groups and replicate EBS snapshots across regions? And that's what Joseph just kind of talked on in security groups. Is you really can't. Security groups are not cross-region portable, or whatever the word might be, and that's where you need to deal with figuring out the firewalls and how you want to handle that. And that's where it gets tricky. And obviously, going even from region to region, and particularly one region to a different cloud, that can be very, very challenging. As far as the EBS snapshots, that's what I mentioned to a previous answer to a previous question. Is right now they do not appear in your S3 bucket, but using some of our tools, and particularly the server templates we have coming out in the next few sprints, you'll be able to upload LVM snapshots to S3, which you will be able to see from any region.
So I'll jump in with one here. We got a question. If there is a private data center with a bunch of VMs, is it considered a cloud? And what is considered to make a cloud? So this is the age-old question of defining cloud computing. We don't really get involved in that much because there's a lot of debate about the definition of what is a cloud. For the practical purposes of RightScale management, we like to focus, as Joseph said, on resource pools. These are resource pools of compute, storage, and other resources, for example, networking and so on, that are available and accessible for management through an API. And the reality is that you can organize internal data center resources, or so-called private data center resources, as a cloud by this definition, and access them through RightScale. And in fact, that kind of a cloud where you might be mixing using an internal data center with an external public cloud, we would call a hybrid cloud. And that offers additional opportunities for high availability and for planning for redundancy and so on. The important thing is that you be able to access these resources in an automated way through an API. Examples of software that allows you to build up a private cloud that we currently support are Eucalyptus and Cloud.com. And our account manager is happy to talk to you about levels of functionality and support there. The important thing, again, is that these are resource pools accessible from a single pane of glass that you can mix and match. In terms of what's a big enough number to constitute a bunch of VMs, that number varies. I will say that we deal with some customers that have so-called private data center clouds that are bigger than other implementations we've seen of so-called public clouds. So, it depends on, your mileage may vary, and it depends on what size data center you use in your business, but definitely that's an option. Are there other questions in the queue here?
Sure, Mike, I'll jump back in. The question here, and it says, didn't the EC2 failure bring down multiple AZs? And Michael kind of went through it at the beginning of the webinar, just sort of a description of what happened. Did it bring down multiple AZs? I guess not technically. It impacted multiple AZs for sure, and that EBS control plane, as it turns out, was a shared resource across multiple AZs within the U.S. East. But did it really bring down multiple AZs? No, but it definitely impacted them, particularly if you were in the affected AZ and were trying to launch new EBS volumes. Another question I have here is, what are reasonable DNS TTLs? I've observed some DNS servers begin to ignore them when they get too small. That's a good question, and unfortunately the answer is your mileage may vary. It obviously depends on what client you're using, as well as what DNS provider you're using. For example, we typically recommend a 60-second TTL on our master and slave records, so that if you did need to promote a slave, there's basically a minute of time where those TTLs expire. A lot of folks will use on their front ends 2 to 5 minutes on those front ends in case a front end goes down and they need to reassign that EIP to another instance once it comes back up. But again, like I said, unfortunately your mileage may vary because DNS providers may have more strict limits than that. Joseph, do you have any more? I'm sorry, I'm sorting through my rest here.
I have a quick one. It says, is latency an issue when replicating data to a slave database in a separate cloud? Unfortunately, there's also your mileage may vary. Usually, it depends on which cloud providers you're talking about and what is the volume of data that you actually will be replicating. The fact of the matter is, unless you have a really, really high replication ratio, latency may not be too bad in terms of what is the time that you are allowing for the slave to be behind, which basically what is the time that you allow data loss in your application. So when things go well, it's really fast, but network hiccups across the public cloud has happened and will continue to happen, so it is something to have in mind.
Here's a quick question. How good is RightScale's Chef support? Is there any documentation about server templates and Chef? So the answer is that RightScale does support Chef. We also support Puppet, and we also support write scripts, which are really basically shell scripts. So we're agnostic about that, but we do have quite good Chef support. And in terms of documentation, please contact us. We do have documentation on how to use them together. It's an area that we're actually also actively working to enhance, but there's a good situation today that you can already take advantage of.
Another question we have here is, in our experience, what is the latency that we've seen between AZs? And to be honest with you, between AZs, it's really very, very fast. A lot of that, we generally do ping tests every so often, and within an AZ, for example, inside US East, Zone A to Zone A, another server, you see like 500 microseconds. It's super, super fast. And even between AZs, some of the ping tests we've done from US East 1A to like US East 1B have been on the order of 1 or 2 milliseconds. So the latency between AZs is very, very low, and it's a very high bandwidth connectivity. Obviously, between regions, you're out in the Wild West at that point. You're on the internet. You're subject to the inherent delays thereof and the routes that may or may not be up or down. So between regions, we really can't answer, but within a region, within the AZs of a region, you'll see very, very fast ping times. Another question that says, regarding stateless apps, what approach can you use besides avoiding connections to resources and those types of things? What a lot of our customers have done, and sort of we've recommended as well, is if you have these stateful apps and you want to make them stateless, save that state in something other than the application server itself. For example, some of our folks will put them in the MySQL database. Others, and that's generally in the lower resource-intensive applications. Others will use things like Membase. For example, we've partnered with the folks at Couchbase. It's basically set up a Membase array, and they've stored session data in that particular Membase tier, and therefore they've allowed those applications to remain stateless. One more question here, and then I'll hand it off to one of the other guys, is, do you recommend multi-cloud setups that involve multiple cloud providers like AWS and Rackspace? Do we recommend that? It's really up to you guys, right? It's really up to your tolerance for cost, complexity. You know, as we've talked about through this whole presentation, it's sort of, you know, you have to play that balancing act between what do I want to prepare for, right? And can we help you set up multi-cloud, multi-region, and multi-cloud deployments? Yes, absolutely. But there are some hoops you're going to need to jump through depending on the abstractions that Joseph talked about that may or may not be available. So do we recommend them? We really leave that up to you. If it's something that you guys want to do, we can assist you with it.
Great. We've got one concluding question here, unless some come in the next few seconds. If I have groups of KVM or ESX hypervisors that leverage Puppet or Chef to manage the config management, how does RightScale fit into that technology? Is it a replacement for vOrchestrator or Eucalyptus? So no, we're not a replacement for Eucalyptus. In fact, we partner with them and run on top of Eucalyptus. And with relation to the other question, as I mentioned, we do work with Puppet or Chef or with plain scripting languages. RightScale does encompass configuration management, but it's really a lot more. You should think of RightScale as a full end-to-end environment, lifecycle management of everything about not just configuration management, but automation, monitoring, auditing, tracking, including cost tracking as well as audit records and so on, user roles and permissions, so when you're dealing with these IT resources, who has access to do what within the system, and then a layer of abstraction technology that enables portability across different resource pools wherever they come from. And all of this combined with and backed up by a services department to help you get migrated over, as well as 24/7, 365 support for what do I do if. Do we have other questions that have come in?
We do, actually. If we
Go
still
ahead.
have time to keep
Fire away.
continuing. Yep. This one's interesting, and actually we should have probably touched on this when we discussed sort of the outage and the implications thereof. The question is, are there advantages to going with the multi-zone option with RDS? For example, they have the multi-AZ RDS. And in this particular outage, no, that would actually have been a bad thing to do. The 45% of the multi-zone RDS instances were affected by this. And that's because the way they've implemented it is it's cross-AZ, and they use multiple EBS volumes per RDS instance to sort of improve performance and improve availability, although it turned out to be the sort of the downfall, if you will. So in this particular instance, no, that would actually have been, unfortunately, about the worst thing you could have done. But it depends, right? Who knows what the next outage may be? It may be completely un-EBS related, and the answer will be something very, very different. So unfortunately, like we talked about, in technology discussions, the answer a lot of the times is it depends. Well, it depends, but in this particular instance, multi-AZ RDS would not have been a good option.
Great. So with that, I think we're getting ready to wrap up. One last note. Those of you who are existing customers who are attending and have add-on questions, first of all, thanks for your business. Thanks for your loyalty, and would be happy to entertain those offline. So please do ping us. And once again, thanks very much for your attention. And
Hey audience, I just wanted to pop in with a quick comment here. This webinar has been recorded. We're going to post it on our site later today. I wanted to thank you also for all of your amazing questions and acknowledge that we've still been getting a lot of questions in the last few minutes. So for those of you who have to take off, I want to respect your time and say thank you. For others who still have questions or who have time to hang out, we've got a lot of unanswered ones. Brian's going to look through and answer a few more for us right now. And all of our guys who are answering behind the scenes, Rob Carr, Jason Altabelli, and Claudio Gentile, the three of them are going to stay on and answer questions too in the Q&A panel. So let's do a few more, and otherwise, thanks so much for your time. Brian?
Great. Thank you, Sarah. And I had a chance to glance over a few of these questions as they came in. Someone here mentions that you've mentioned app server, load balancing servers, database servers, et cetera, in your high availability chart. What about monitoring and support servers? Things that are running, Munin or, whatever it is that you might be, or Nagios, whatever. Well, sort of what do you do about the watching the watchers, right? So, yeah, it does make sense maybe to have watching the watchers servers, but again, you have to plan for everything can go down. So as far as distributing those monitoring servers, it makes sense to put those in multiple availability zones as well. We always recommend that. And depending on your needs and your pain thresholds, it might make sense to have them in multi-regions as well, with the same caveats coming into play that you then have to worry about the latency and cost of that traffic transfer. But it always makes sense, and our general response is always distribute, 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 because AZs can go down. We've seen that in the past, and then multiple AZs can be affected. We've seen that in the more recent outage that AWS had.
So just a quick add-on to what Brian was just saying. For whoever's not familiar with RightScale, we do provide this service as part of our platform too. So you don't need to have your monitoring and alerting servers monitoring your application. You can basically use that service from RightScale itself and let RightScale worry about replicating, monitoring servers, and everything else across clouds and regions.
super. Well, we've come to a little even past the end of the hour, so we're going to go ahead and wrap up now. Once again, thanks very much for your attention. I think it's important to remember that, as our CTO Torsten said in his blog, it's really still day one in cloud computing. It's very early in the evolution of cloud computing. We're very excited about the levels of HA and resiliency that can be achieved through the cloud. We're also open to learning any other ideas that folks have. One of the characteristics of RightScale, it is an open platform. And so we'd love to hear those of you who have thoughts on ways to design resiliency and high availability into various kinds of applications and componentry. please let us know. Those of you on the east coast of the U.S., a reminder, as it says on the bottom of this slide, we have a live user conference that will be taking place in New York City on June 8th in coordination with the Cloud Expo conference. It's free. You can go to rightscale.com/conference to register and sign up. We'd love to have you join us in person to talk about all of this further.
Once again, thank you so much for joining us today. When you disconnect from the webinar, your browser will pop open a really brief exit survey. We'd love your feedback on this webinar, as well as if you have any specific projects that you'd like our advice or thoughts on for having high availability in the cloud. Just there's a question there. Go ahead and answer that, and we'll reach out and we'll help you get that addressed. Again, thank you so much for your time. We hope this was useful, and have a great Friday and a great weekend. Bye, everyone.